concentric cylinders means what? You have one cylinder of radius A. You have another cylinder, one more cylinder, radius B. So one cylinder radius A is inside another cylinder of radius B. Step 1. Notes बंद कर दो. So the problem statement is one cylinder, radius A, another cylinder, radius B. We have to find out the capacitance of the two. Step 1. Yes? Step 1 is what? Connect voltage battery V0 across the two. The one which is connected with the positive charge will have, the one which is connected with the positive plate will have a positive charge. The one which is connected with the negative plate will have negative charge. So the outer cylinder will have negative charge. Inner cylinder will have positive charge. Step 1. Connect voltage, that is battery, across cylinders. Step 2. Yes. Find out what? Electric field E between the two. How E varies between these 2 points, A and B. E you have to find out as a function of R. So find E when R varies between A and B. 2 minutes with you, one full page. Procedure. Let there be a point P. At what distance? R. Hypothetical cylinder. Gaussian surface you call this. At what distance? R. Length of all the cylinders is L. E represents what? Electric field. Number of lines per unit area. If the charge is Q, the number of lines is Q by epsilon divided by area. Yes. Area of the cylinder is curved surface, only curved surface. This is 2 pi r. If you open this, this is 2 pi r into length L. It is 2 pi r L. Q by 2 pi epsilon naught L into 1 by r. How E varies with r? Yes, E is inversely proportional to r. E is inversely proportional to r's power 1. Completed. 1 minute. Step 3. Yes. Step 3 is what? To find a potential difference, voltage difference magnitude is equal to what? Yes, area under ER graph or integration of E. That means what? EDR represents what? E into DR represents this small area. This is E, this is DR. So this small area is EDR. Total area under the graph is what? Integration. E is equal to what? E is equal to Q over 2 pi epsilon naught L 1 by R dr. If you integrate this, Q 2 pi epsilon naught L is constant, you can take it out. So it is integration of 1 by R. Q over 2 pi epsilon naught L. Integration of 1 by R. Yes. Integration of 1 by x with respect to x is log of x to the base e. So integration of 1 by r is what? Log of r to the base e. You call this natural log. R varies from a to b. Put a value. First of upper limit minus lower limit. Two pi epsilon naught L. Yes, log of put r equal to b. Upper limit b minus lower limit. Lower limit is a. Put r equal to a. What you get is q over 2 pi epsilon naught L log of, yes, log of a minus log of b is log of a by b. It is log of b minus log of a. Log of b by a to the base e. So this is your potential difference. Delta V potential difference in this case is equal to what? Applied voltage V naught. So V naught is equal to step 4. Try step 4 at your own. Purpose. You want to find out the capacitance. Capacitance as per definition is what? Try. 1 minute with you. Find capacitance. Capacitance is equal to charge per unit voltage. Write value of Q by V naught. Q by V naught is equal to what? It is equal to 2. This is Q, this is V naught. If you shift V naught here, 2 pi epsilon naught L you get to the other side. 2 pi epsilon naught L divided by log of V by A. This is capacitance. And in case you want to find out capacitance per unit length, answer is 2 pi epsilon naught log of B by A. This is capacitance per unit length. Why it is so? Not in the previous case. When you buy rope, the price is always rupees per meter, 20 rupees per meter. Chain, wire, price is always per unit length. That is why it is also capacitance per unit length. if there is any material in between the two, suppose there is a material with the relative permittivity epsilon r placed in between the two. If you place some material here of permittivity epsilon r, then capacitance per unit length expression is 2 pi epsilon naught into epsilon r. This factor, this parameter is extra, log of b by a. 1 minute to complete. Refer to numerical number 9. Numerical number 9. A cable consists of a wire 3 millimeter in diameter, is insulated with 3 millimeter thick dielectric of relative permittivity 10. Calculate the capacitance of 1 kilometer length of the cable. Draw the diagram. There is a cable with a certain value of radius A. On this you have insulation. This is insulation material. This is insulation material. This thickness is also given to you. Total radius is B. First you need to write A and B. It has nothing to do with plus 1 plus 2. It is a school work. Write value of A and B. Yes. Cable consisting of a wire 3 millimeter in diameter. Diameter of this wire is given 3 mm. What would the radius of the wire? A 1.5 millimeter is equal to 1.5 into 10 raised to power minus 3 meter. Insulated with 3 mm thickness of this blue color material, this thickness is further. A is 1.5 mm, this is 3 mm. Total B comes out to be what? Yes. This distance from the center 1.5, this is 3. Total is how much? 4.5 mm. 4.5 mm. B is 4.5 mm. 4.5 into 10 raised to power minus 3. Epsilon R, yes, 10. You have to find out capacitance for how much length? 1 kilometer wire or cable. Formula is given on the board, but this formula is for capacitance per unit length. So this step 1 capacitance per unit length, that means per meter, is equal to 2 pi epsilon naught epsilon r log of B by A to the base E. Units will, if all are in SI unit, you will get farad per meter. Find out. Two pi epsilon naught. 2 pi epsilon naught is 8.854 into 10 to the power minus 12. Epsilon r is equal to what? 10 log of B by A, log of 4.5 over 1.5 to the base E is log of 3 to the base E. Approximately, let me write it as 1.1. It is a table base parameter. Log of 3 to the base E, say 1.1. Calculate and come out with the answer. You get farad per meter. You need to find it for 1 kilometer. That is for 1000 meters. It is approximate. This value is approximate. That is why you will have close answer approximately equal to this. This part comes out to be what? Yes. First part comes out to what? Yes. 4.96. Approximately 5. Can I write 5 into 10 raised to the power minus 5? Yes, please come out with the correct answer for power. 5 into 10 raised to the power minus first part only, not for 1 kilometer. That is the second step. Only first step, capacitance per unit length. This is 10 raised to the power minus 12. This is 10 raised to the power 1. So, what you get is, yes, in farad per meter, yes, comes out to be what? 5 into 10 raised to the power what? Yes. How many of you getting 10 raised to the power minus 9? 1. 10 raised to the power minus 9. Let me write 10 raised to the power minus 9. Farad per meter. Step 2. Yes. Step 2. Capacitance is equal to what? This is capacitance per unit length. Capacitance is equal to capacitance per unit length into length. It is equal to what? Yes. Capacitance per unit length is 5 into 10 raised to the power minus 9 farad per meter into length 1000 meter. What you get is, yes, 5 into 10 raised to the power minus 6. This was, unit was farad per meter. Meter cancel. What you get is 10 raised to the power minus 6 farad. 5 microfarad. Please check. Power 10 raised to the power minus 10. How many of you are getting 10 raised to the power minus 10? How many of you were getting 10 raised to the power minus 10? You need quality calculation. This was not 10 raised to the power minus 9 in the previous part. It was 10 raised to the power minus 10. So make a correction. If it is 10 raised to the power minus 10, then it comes out to what? 0.5. 0.5. So you will calculate once again at home and confirm whether you are getting this answer or not. Concept is simple, formula is correct. If there is any mistake, it is on calculation part only. How many of you are getting 0.5 microfarad? 0.5 microfarad. Fine.